Given a string S, return the number of unique palindromes of length 3 that are a subsequence of S. Note that if there are multiple ways to obtain the same subsequence, it is only counted once. Palindrome is a string that reads the same forward and backwards, and a subsequence is just a substring with some of the characters removed. So long as it retains the same order, it's considered a subsequence. So this is actually a pretty straightforward problem. We're given a string, and we just need to make some subsequences out of it, so long as they're just 3-letter palindromes. So looking at this, we can make 3 different subsequences. We can take this A, B, and A to make ABA, a palindrome. All 3 A's, so AAA, or ACA, ACA, to make a palindrome. Again, we're not actually returning the actual string, we're just returning the number of palindromes that we can make. So typically when I see palindrome questions, I usually think to myself, okay, let's do some sort of 2-pointer solution where we look at the front and the back and we say, once we find 2 characters that match, we could just iterate over the inner portion of the substring. But as I was working through this, I found myself unsure of how to either move the left or the right pointer. So while I did think this was a good approach, it needed some modification. I also recognized as well that we needed to look between any 2 similar characters and see if there was a palindrome within those 2 character substrings. So for example, BB, this is the only substring, so we can't find anything there. But what if we had this BB? We can find that C, or BAB, or really any other substring if this was expanded out at all. We could look between any one of these substrings where there are similar characters if we were to just take the indexes of these characters and put them into a dictionary. If that doesn't make sense, just hold tight. Let's actually set up the dictionary and then it might make more sense. So we're going to start off with a default dict. We're going to iterate over the characters in S, and for each character, we're going to append its index to the list. And this is going to look like this. And you might be saying to yourself, all right, this is great and all, but what does this actually get us? Well, I want you to recognize something. If we have a situation where we have a character that has more than 2 spots and its distance is more than 2 away from each other, then we're guaranteed a palindrome. And why do I know that? It's because A appears in 2 different places, and there are characters between it that can either be itself or another character. And that is the criteria that we need to create a 3-sequence palindrome where we're able to remove other characters between it. So all our algorithm is going to be is iterate over our initial string, log the indices of all the characters, and then iterate over each one of these arrays. If we have a situation where the array is greater than or equal to 2, then we need to investigate the elements in it. If the difference between any of these subsequent elements is greater than 2, then we know that we have a palindrome. So we're just going to add it to a set and return the size of that set. So let's create a set and let's iterate over the characters within our dictionary. We're going to get the index array of those characters, and now we're going to look between subsequent elements in those arrays. So I'm just going to say array index 0. While true, we're going to set our left and our right pointer, the bounds that we're going to iterate over, and we're going to add each one of those elements to our set. If our right element, this right element, exceeds our index array, we're just going to break out of this loop. And just to optimize this a little bit, we're going to say if our subsequent elements, if the distance between them is not greater than 2, we're just going to go to the next elements in our array. We probably won't need this else, but I'm going to put it here anyway. And I just forgot to mention that we need to move our index over every time we go through all of the elements. Again, if this isn't clear, this portion is just iterating between 1 and 4 within our original string. So between here and here. So now let's finally return our set. Now let's finally return the length of our set, because this should have all of the palindromes within it. If we hit run, we're actually going to run into an issue. So what is that issue? It looks like we're 1 off. So let's just take a look at what that set returns us. Print that set, run again. And out of the answers that it gave us, it looks like we're missing that AAA solution. And that makes sense. We're only iterating between 2 of the same character, our algorithm will never allow us to find a triple of a character. But there is a pretty simple solution for this. So long as we have 3 or more characters within any one of our index arrays, all we have to do is just add it to our set before we do our algorithm. So let's do that. If the length of that array is greater than 2, just add 3 keys together. These are just strings, so it's just going to do concatenation and then add it to our set. Now let's run. Looks good. Let's submit. And there we go. Like, subscribe. A link to the code will be in the description. Join our Discord for some extra help, problem suggestions, and announcements. And I'll see you in the next one.